Dear friends, in this last lectures, we have learned this how this inductance matrix will be. I hope you can see my screen. Due to the power supply issue, I couldn't be able to continue with the same lecture. Take this is the consider as a phase 2 of this our modeling of electrical machine under induction machine by writing this equation in using by observation. So let me share this here. We have written like this in the last class, and this m already we know ls is equal to lls plus 3 by 2 lms. The 3 by 2 lms, this is coming due to that conversion of a 3-phase to 2-phase conversion. This constant is coming 3 by 2. Then similarly we can write m is nothing but mutual inductance. We can write minus 3 by 2 in the mutual inductance between stator and rotor, so that we can substitute for this m as mutual inductance between stator and rotor 3 by 2 AMSR, and you can substitute this ls as LLS plus 3 by 2 LMS. Similarly LR as LLR plus 3 by 2 LMR. So like that we can substitute. That's what we have derived in the last lecture. Last lecture, this values 3 by 2 LLS by 3 by 2. This we will get. Then you can write it in this compact form of L alpha beta naught is nothing but we can have this matrix as, you can take it as LS matrix. So this matrix combinedly you can take it as MSR matrix. Then this will be, already told you, this will be the transpose of this matrix. So MSR transpose. Then we can have this matrix as inductance, rotor inductance matrix. So we can write LS MSR. You can, this is also separate matrix. Then similarly we can write MSR transpose matrix. Then we can have LR matrix. So this way we can write this equation. Now we, from this previous thing, I have completed. Already we have derived this equation as V alpha beta naught equal to I alpha beta naught into R alpha beta naught plus L alpha beta naught into d by dt of I alpha beta naught plus G alpha beta naught into I alpha beta naught into omega r. This omega r is d theta r by dt. Like that, this is the form. We have written this, we know this, we know this, we know this one, and L alpha beta naught, I alpha beta naught. Then we have only the variable is G alpha beta naught. So we can call it as speed EMF term. The speed EMF term, how it will, we have to derive. For that, I think due to that let me go to the next slide, and where I will explain how already we know we have, this is the stator alpha S, and this is the beta S. Then we have, this is alpha R, and we have beta R. Then angle between these two will be theta. So this is how we have taken it in account, 3-phase to 2-phase system, and from that only we have, so separate winding we have here, one winding, here one winding, and this place and this place. So this is V alpha S, and this is V alpha R, then V beta S, then V beta R, then this total angle is theta. Like that we have Done. Now, from this, we have to write this speed EM of term G alpha beta naught. So, as like mutual inductance, this is we have to concept wise we have to understand. Normally, power is nothing but torque into omega of the motor, right? So, this torque has the component of field component and flux component, right? So, totally we have this. Component, if this both these two are perpendicular, whenever the flux component and field the torque component, it should be always perpendicular to each other. This angle, this is flux and this torque component, and these two, the resultant of these two will be draw the current. So this is the maybe you can take this is the torque component and flux component. So this is the current component which has these two component, torque and flux. So accordingly, whenever these two axes of windings, stator and rotor, have stator component with the stator current component and the rotor current component perpendicular to each other, we will have the speed EM of term will be maximum. Otherwise, speed EM of term will be minimum. Right. So for that, I can write this speed EM of term G. G is nothing but we can write some component G, so that maybe you can take that mutual inductance effect. So we can write mutual inductance into sine theta, sine theta. So whenever theta is equal to 90 degree, we will have maximum value of speed EM of term. Whenever theta equal to 0 degree, we will have 0 speed EM of term will not be there. So this way we have to write this equation. G alpha beta naught can be write it as let me take in this way. Here alpha S, then beta S, then naught S, alpha R, beta R, and naught R. Here alpha S, beta S, naught S, alpha R, beta R, naught R. Now alpha S in the same axis, so we will not have any speed EM of term. Alpha S, beta S, but both are in the stator winding, so we don't have any speed EM of term. Then alpha S, this also have the stator winding, so it will be 0. Then similarly, this all are about the stator, so that we can have beta S, alpha S, beta S, beta S, beta S 0. Then 0, 0, 0. Similarly, all the rotor variable alpha, same axis, so we will not have any speed EM. Therefore, alpha r, beta r, this will be 0. Then similarly, this 3 component beta r and alpha r in the same stator, so rotor one. So this is the rotor alone, so this is the stator alone, so we will not have any field EMF, sorry, speed EMF, since angle between these two are, even though this angle between these two are 90 degree, all are in the only one component. There is no interaction between stator and rotor. Now we can say alpha S. Alpha S, you can write it as alpha S alpha R. So this is alpha S alpha R. We can write M S R into sine theta R. Let me take some space. That is M S R into sine theta R. Then what we have? Beta, alpha S beta, alpha S beta. Alpha S beta means sine of 90 plus theta. What is sine of 90 plus theta? Sine of 90 plus theta, we can write it as cos theta. Therefore, we can have ms. Sorry, we can write this is m into cos theta. Then alpha S theta, this is no contribution with this 0 axis, since this is a balanced. Then beta s alpha r sine of 90 minus theta. Sine of 90 minus theta we can write m into cos theta r. Then beta s is here and beta r is here, so that we can write m into sin theta r, then it will be 0, 0, 0. Then similarly in alpha r beta alpha s, if you write like this, this is the transpose of this matrix, it will be there m into sin theta r, then m into cos theta r, then 0, then we can have m into cos theta r, then m into sin theta r, then 0, 0, 0, 0. So this m is nothing but 3 by 2 into MSR. M is nothing but 3 by 2 into MSR. Then one more thing we have to consider here. Now we are here in this equation, we are writing the alpha s is the reference, right? Alpha s, take this reference this direction. So in this case, alpha s is lagging alpha r, so that I am writing here one minus, right? Minus, I have started this way. We can write it by observation, this equation. Similarly, this again alpha s alpha beta, again it is lagging, so we can write this in this direction. Beta r is leading, alpha s is lagging, so minus. Then in this equation beta s alpha, beta s, where it is beta s, alpha r is in this place, so beta s is positive, beta s is leading, so I have written here positive. Then beta s beta r, in this case beta s is leading, beta s is lagging, therefore I am writing here one minus. Now this is the transpose of this matrix, right? Therefore I will write here minus, then plus, then minus. This way we can write. So already we know this is the matrix of, assume that you can take G12 matrix, then we can write this entire matrix as, you can take this 3 rows, entire matrix as G12 transpose. So you should know what is m. M is already defined 3 by 2 into MSR. So that we have written this equation here, this speed em of term. Then in this case we can write inductance, we have derived, then the speed em of term, inductance matrix, then finally end up with the speed EMF G alpha naught. See here minus 3 by 2 MSR, minus 3 by 2 MSR sin cos theta, 3 by 2 MSR minus 3 by 2. Just this is the transpose of this matrix. So with this we can understand how one can write this how one can write this equation in this form. So I hope this first we have studied about this inductance matrix, and then we have studied about some problems with some signal. Sorry for the interference. So we understood how one can do with this inductance matrix, matrix, how we will write the induction motor. Similarly, how the speed em of term will be. So from this we can directly write this equation, how in this ABC to alpha beta, without going to the tedious process of derivation. The next lecture I am going to explain how to write this, derive this equation of stator attached reference frame and rotor attached reference frame. Then finally orbital reference frame, how how it will be each models. In the further lecture, I will explain. I hope you understood the concept, what I am explaining to you. Kindly subscribe this channel if you have not subscribed till now. And if you have any way, if you are watching it in this Facebook, just to show your impression by pressing like or dislike, and share to your friends also if you feel that it is worthy. Wish you all the best. Thank you.